This shape has become one of the most recognizable symbols of industrialized drone warfare. Deep within Iran's industrial core, the assembly of Shahed drones unfolds with precision. In modern warfare, some of the most important machines are built far from the battlefield. Fixtures and alignment tools help turn rough industrial output into standardized final units. At this stage, the factory floor feels less like a workshop and more like an assembly doctrine. This shape has become one of the most recognizable symbols of industrialized drone warfare. Mass production only works when inspection is built into the rhythm. But this is not just a weapons story. It is a factory story. Some flaws are found by machines. Others are still found by trained eyes. Today, we explore the industrial ecosystem behind Iran's Shahed drone program. Rejected sections are isolated quickly, so the main line never loses pace. How does a system like this scale from secret workshops to a mass production pipeline? In systems built for quantity, acceptable consistency becomes the real benchmark. The answer begins with demand, low cost range, repeatable output, and industrial persistence. Initiate test sequence, vital stable proceeding beyond inspection. Another layer, the culture of controlled testing. In this model, scale matters more than elegance, and repeatability points toward volume, survivability, and rapid throughput. Not every system is tested the same way, but every production line needs confidence checks. From the outside, they can appear almost anonymous, just dress-stored steel and style with Toro lens. In batch manufacturing, reliability is often statistical as much as individual. Some parts arrive in bulk boxed, tagged, and move through controlled internal channels. Before anything is assembled, everything is sorted, counted, and standardized for flow. Some stages move outside into isolated proving grounds, designed for distance and secrecy. This is where the industrial scale becomes unmistakable. A production system succeeds not only through design, but through organization. In programs like this, supply chains do not advertise themselves. They hide inside ordinary commerce. One unit can be improvised. Hundreds require a system. Shipping networks, intermediaries, and layered procurement all become part of the factory story. Finished units do not always move immediately. Storage handling matters. Damage between factory and deployment is just another production failure. The key is continuity, keeping the line supplied despite scrutiny. This is less about luxury and humor. Crates, tags, and serial logic transform machines into trackable industrial assets. Panels are measured, cut, and formed in repetitive routines designed for consistency. Molds, jigs, and templates turn one off. Fabrication into industrial rhythm. Once packaged, the line hands over to logistics. Movement may happen at night, under conditions that prioritize concealment over spectacle. The goal is not artistry. The goal is repeatable parts produced at speed. Factories are only one half of the story. The other half is getting output where it needs to go. Even low-cost systems depend on discipline, tolerances, and basic quality control. Depots, transfer points, and storage yards extend the factory beyond its walls. Once materials become parts, the factory shifts into sub-assembly mode. Each station performs a narrow task, making scale possible through specialization. Behind the machinery is a workforce rarely seen, and even more rarely named. In factories like this, human rhythm becomes part of the machine. Shift changes, routine checks, and repetitive labor form the hidden heartbeat of the operation. Output depends on timing, supervision, and controlled workflow, not just equipment. In secretive industries, even labor can become anonymous infrastructure. A program like this is not built by one kind of worker. It is built by an ecosystem of them. Another layer of the story lies in electronics. Handling and integration bench testing helps separate usable modules from failures before they disrupt the line. Wiring management is unglamorous, but in volume manufacturing, it becomes essential. No production line survives on parts alone. It depends on power error, climate control, and maintenance. Maintenance is where output is protected before failure becomes visible. Modularity allows damaged, delayed, or rejected parts to be swapped without stopping everything else. Every spare part on a shelf is really time, save for the factory line. Eventually, separate streams of work converge on the integration floor. This is where the factory begins to reveal the recognizable form of the system. Some of the most important work happens away from the line, inside rooms that watch the whole system. Facilities may be distributed, layered, and compartmentalized to reduce vulnerability. In this ecosystem, concealment is not an afterthought. It is part of the production model. The less visible the chain, the more resilient it becomes under pressure. What looks like one factory may actually be a network of specialized sites. Distributed production can absorb disruption, spread risk, and preserve output. The program behaves less like a single plant and more like a living industrial ecosystem. At the center of this model is a simple question: how many can the system keep producing? Mass production rewards standard routines more than beautiful complexity. Everything is shaped around keeping material, labor, and timing in alignment. By the time output reaches deployment pipelines, the factory has already done its work. When the system favors quantity and persistence, factories become strategic weapons in themselves. The battlefield sees only the final object. The factory sees the entire chain behind it. Once it leaves the line, industrial output becomes strategic effect. But no factory exists in isolation. International pressure reshapes what can be sourced, shipped, and sustained. Under restriction, the industrial challenge becomes adaptation. As much as production, the durability of the program depends on whether the industrial chain can keep absorbing pressure. Global scrutiny often begins with a political statement, but it ends in warehouse aisles and procurement desks. What we are looking at is not just a machine, but a manufacturing doctrine. Its public image is dramatic, but its private reality is repetitive, logistical, and industrial. That repetition is the real source of power. The real question is no longer what one drone can do, but what an industrial system can keep producing. Across modern conflicts, the factory floor is becoming as important as the front line. Industrial capacity now shapes endurance, pressure, and strategic tempo. In long wars, what matters is not only technology, but whether factories can keep breathing. Low-cost, scalable systems change the economics of conflict by turning volume into strategy. And so the story returns to where it began, behind gates under lights, far from public view. Because in the end, the most decisive part of the system may be the part no one sees. What looks simple in the sky is often supported by a far more complex system. On the ground, factories, workers, logistics hubs, and procurement networks all combine into one industrial ecosystem. The battlefield may be distant, but the factory has already entered it. And that ecosystem tells us something uncomfortable about the future of warfare. In this era, scale, logistics, and repetition can matter as much as breakthrough technology. What we see is not just a drone shape, but the shadow of an entire production network. And behind that network stands the place where modern conflict increasingly begins: the factory gate. This was the industrial story behind Iran's Shahed drone program. A story of materials, labor, secrecy, and scale. Thanks for watching.